I want to introduce you to Ying-Jung, who will talk about climate change and how we can help. And maybe you all can help. And maybe at the end of this talk, you will be very into this and will join her on this journey. Yeah. So Ying-Jung is an environmental scientist, turned data scientist, and has a PhD in environmental science from US Santa Barbara. Yeah, I will stop talking here. Enjoy the presentation.
So can you guys hear me now? Yeah. Okay, yeah. Thank you guys coming to my talk, and good afternoon. And it's my pleasure here today in the Seattle. So it's very meaningful for me because here is I got my first job in Seattle. Right now I'm working as an applied scientist at the Descartes Lab, which is a startup, and it provides geospatial analytics because I'm a geographer and environmental scientist. So we are working on this kind of solution for big corporate and also nonprofit. And my work experience has been from like academia, big corporate to startup. And this three circle, which is a nature disaster event and ecological system, and also hydroclimate system, is something I focus entire my career. And my interest is about time series analysis and forecasting and spatial analysis. Also some computer vision model, because our startup right now is focusing on satellite image to do a lot of machine learning and deep learning model. And here is a free, open source, and transparent visualization of carbon intensity of electricity consumption around the world maps. We call electricity maps. I don't know if you guys heard this before. And I heard this like pretty much last year. And I joined the OpenAI climate change hackathon. And then they got this idea. So one of our teams saying that we want to do some like carbon coding, green coding. So we figured out this data set could be useful. So that gave me this idea, and I dive into this side project journey. And this could be a part of third-party and open source data. Little bit about agenda today. So we'll talk about why should we care about this, and also energy consumption measurement. So I apologize, the first two parts will be very, very boring. So more like an energy class in the school. And it's not related to coding here. And for the third part will be the open source tool. And this tool will be focused on three. One is a Carbon Awareness SDK, which is developed by Microsoft and also UBS and also Green Software Foundation together. Recently, they just released the white paper. And also there's the other one, my favorite one. It's called Cold Carbon, which is very easy to use. I will do a live demo. And later on, we'll go to a platform. It's called Cloud Carbon Computing, something, I forgot, sorry. I'll look at later. And then we do some future outlook, which is my reflection about using these tools and how this could help to fight the climate change. Sounds good? Yeah. Okay. And so why should we care about this? Because we want to do environmental sustainability. So what does that mean? It means the ecological balance in our planet's natural environment and conserve nature resource to support our well-being and the future generation. So that's environmental sustainability. And there's like social sustainability and also ecology sustainability and economy sustainability too. And because in the UN and also IPCC, they plan to reach the net zero carbon emission goal by 2050. So that's why we need to care about it. And how do we do the mitigation? So we do like producing less carbon dioxide and also using energy more efficiently and also choosing electricity over fossil fuels and also focus on less emission. That's the way we can do about environmental care. Sorry, is something wrong with my laptop? Yeah.
Maybe when it falls asleep.
Okay. Okay, sorry. Sorry, my laptop, it's kind of old and falls asleep. Yeah. And so because a lot of corporation is like transition from on-prem data to data center cloud computing. So there's like data center and data transmission network. And this data center and cloud data center is actually account for nearly 1% of energy-related global greenhouse gas emissions. This will be increased in the future. And major cloud providers such as like Azure, AWS, GCP will match their cloud energy consumption with carbon-free energies through power purchase agreement. So this is like an agreement to do the carbon neutral measurement. So the way we care about it is decarbonize the grid. So it's decarbonize the energy consumption. So how we do it, here is the example about supply and demand over time for a grid with the mixed-generate stack. So you can see the green one is from solar, and so this is an example from the California. So there are times in California where those is oversupply of solar power in the middle of the day, and then the clean electricity is being discouraged. So that's actually the orange one. And consumption more electricity at those times will cause no additional emission. So that's the way we can do by using clean energy. And you can see the gray one is actually coal, and I believe it's a fossil fuel, that kind of types of energy. That's a way we can do more like a less emission and using more clean energy. So there's a term in the white paper they mentioned about is carbon awareness. So what is carbon awareness? It's doing more when more energy comes from low carbon source. So such as like energy is like clean, and also doing less when more energy comes from a high carbon source. Okay, so such as coal. And also like I mentioned from the graph, it's more like a time shifting. So this can shifting by ultimate impact by shifting workload from one location has maybe like in the middle of time using solar, and then the other time zone different can use in the other time zone solar. So it's more like location-based margin carbon intensity for each of the data center. And this also indicate the location shift. So this can optimize impact by shifting workload between this location. And also demand shaping. So running software, so it does more when electricity is clean and less when it's dirty. So it's about how we use software and how we do the demand. So there's a way, so this actually I grabbed a slide from another PyData talk in Berlin. It's about green coding. So they do the energy consumption measurement. So here there's a very important idea. It's about carbon intensity. So what is carbon intensity? It's about amount of emission of carbon dioxide released per unit. And there's some other way you can generate like from electronical, from AC and DC, and also software, such as CPU usage. Like if you use the software hardware like 100% CPU, then it will emit much more carbon dioxide. And there's a like sensor on the chips too. And they focus on this with about different measurement about CPU per core and also software model capacity reading on main board. So that's basically how you control your hardware choosing into your software. And here is another concept. So this concept is about software carbon intensity specification. And this is proposed by Microsoft, UBS, and Green Software Foundation again, which is called SCI specification. So this equals to energy consumed by a software system measured in kilowatts and multiplied by location, marginal carbon emission like we mentioned before, and carbon emitted per kilowatt of energy. And this will plus the embedding body of the software system like a hardware system, and the software is running. So per rate, it's a function union, which is how the application scale. So like per extra user or per API call. So when you call the ChatGPT API, and that's something you will emit the carbon. So that's how I'm going to talk. So have you guys used the ChatGPT before? Raise your hand. Wow, pretty much the forerun using the ChatGPT. So we know that ChatGPT is original from GPT-3. So when doing the ChatGPT from the training, it's like approximately about using 1,287 milliwatts and produce 552 tons of carbon dioxide. So that's a lot, right? So what about running the ChatGPT? So when we ask a question. So how much carbon produced from ChatGPT? Can you guys answer me? I mean, anyone want to guess? Sure. 5,000? Okay, let's see. So ChatGPT's daily carbon footprint could be like 23.04 kilogram carbon dioxide, and this is from ML carbon dioxide impact calculator, and this is a hyperlink. And every day you run the ChatGPT could be approximately about 0.2% annual carbon footprint of Denmark. And if you're using the ChatGPT annually, so the carbon footprint will approximate about 76% of Denmark for the whole year. So that's kind of a lot, right? So are we supposed to use the ChatGPT now? I don't know. Okay, that's something we can guess about how we use the software for like carbon emission, and maybe we can use a better time and better location with clean energy. Okay, so let's dive into more coding part. So here is like Carbon Aware SDK. So this SDK is again developed by Microsoft and also Green Software Foundation. And their goal is trying to be environmental responsible and mitigate climate change and reduce greenhouse gas emission. So what they will do is actually perform with a different shifting and time demand. So that's actually the carbon intensity we just introduced. And then there's like different times of day you can shift from like coal and to the green energy, so like clean energy. And how they do it is just like optimize experience from this. And also this can implement a carbon aware computing, so which means that lowest possible carbon emission. And here is their actually open source link from GitHub, and they actually have 3 or 4 features. One is a carbon footprint estimation tools, and also they adding the carbon data inside this API. So actually they not only provide their own data, but also from water time and also the electricity maps we just saw. And that's one feature. The other feature is a coding portfolio and optimization. Like we mentioned, we can optimize our code and do much more portfolio for coding. And in the Green Software Foundation, they also do a green coding best practice with Microsoft and the other partner, Water Time. And also they integrate with the clean energy, which means a renewable energy source. So here, I'm going to show you guys how this web API doing, and they actually have a YouTube video here. So let's play the YouTube video.
Steps to run the SDK on your local machine as a local web API endpoint. To get started, go to the Green Software Foundation repository on GitHub and look for the Carbon Aware SDK project. Once there, copy the git clone URL, switch to a local terminal, and start cloning the repository. You should then see a list of folders appearing on the side, of which we are interested in browsing to the web API folder, so we can run the API from there. So let's browse to that folder by going into Carbon Aware SDK /src/ carbonaware.webapi/src folder. In there, we will use the .NET Core SDK already pre-installed on the machine to run the API from that local folder. Once the project is compiled, you will see a URL in the output that you can use in your local browser, suffixed with Swagger to access the Swagger definition of the endpoint. Once loaded, you will see a list of all the endpoints available by the web API, as well as a comprehensive documentation of each one of those endpoints. Each endpoint offers a concise description of what the endpoint offers, a list of available parameters and their descriptions, and the ability to try this out straight from the browser. Let's give it a go straight away by proceeding to a location shifting scenario, where we are looking to understand which of a few locations offers the best carbon emission at a given time. So in this case, we won't be specifying any time, which means that it will run for right now for the given locations. Also note that those locations are Azure regions. So here we have UK South, North Europe. I have to have North Europe again, actually, sorry. Click on execute and it will tell you which location offers the best carbon emission rating. In this case, we have 59 grams per kilowatt hour. Feel free to explore all the other endpoints available. I hope you found this video useful. Good exploration and good luck with your projects, and thank you for watching.
Yeah. Thank you. And that's kind of like short video about like presentation for the carbon coding. And right now we dive into the other one. So it's Code Carbon, which is another open source package work by measure the energy consumption of computing device. So using factors such as like hardware, electricity consumption, and data center location to estimate carbon emission. So you can see there's a figure here. It's like a GPU and also CPU and also your RAM. So this is your hardware energy consumption multiplied by the regional carbon intensity of electricity. And this is actually an open source package written by Mila, which is the academia institute. And I personally like this one because it's easy, and also I will do a live demo later. And this is a Python based, and also it's IAPO based, which is we just mentioned about the chips and different hardware, and also supports the NVIDIA GPU. So basically, when you have a deep learning model like TensorFlow here, you just use from Code Carbon import emission, and then they'll give you some each of the RAM and emission. I'll demonstrate later. So here, they not only give you some idea about the coding there, but also give you a dashboard. So this dashboard give you about the location and how much you can consume here, and they're basically meta info. So basically, that's kind of the dashboard. And now it's another demo time. So this is several lines of code from emission tracker and tracker emission start and stop. So let's do a live demo here. So can you guys see my screen? So this is a VS Code, and I do a model. This is a CNN model. So when I hit the Python and model.py, so you can see it's kind of thinking right now. Okay, Code Carbon. It counts full CPU, and then this is my laptop, and there's a file already download, verified. So it's taking a little bit of time here. So it can give you energy consumption for RAM, 4.63 watts. So this is how it took, and then because this model is not very efficient, optimized, so it probably will take about like an hour. I think I run this before. And so you can see from this running, testing with your own model, they will give you some more like very easily accessible idea about your own hardware and the carbon emission. So that's it. And then I give you some like screenshot when I run before. So here is the same information. It's still running. And when I do the interruption, and it give you the count. So for old CPU, the old CPU power for about 42.5 watt, and that's kind of the way we're doing after I do the stopping. So right now my background still running with the cold carbon program, yeah. So that's basically the cold carbon, and I like this one better than the other one, yeah. The other one is more like web browser, but you can explore on your spare time. And next, we're going to cloud computing side. So there's other API is called Cloud Carbon Footprint, and this is an open source tool to estimate energy use, so kilowatts per hour and carbon emission, like metric tons for each emission from the public cloud. And they give you this kind of dashboard. And the feature for them is actually have input data from different cloud provider and types of size of resource, such as virtual machine, storage bucket, and database from each of the data center region. And then this gives you the estimate for the energy use and associated carbon emission of the resource you choose. And then each of the cloud providers, such as Azure, AWS, will have their own commitment to renewable energy. So that's basically you choose how you use the clean energy and do the carbon offset initiate. And this will give you the overall estimation about carbon emission associated with your organization's cloud storage and cloud usage. So for my current organization, we're also using a lot of clouds from like AWS and also used to be GCP, yeah, but not the Azure here. So here's more about demo. That's going to the web browser. And so you can go to the cloud carbon footprint here. So there's a old provider. So when I do just like Azure, because we're in Microsoft, and then account, we have a full file account, and service is like one virtual machine. And we can see 1 month, how Azure is doing. Maybe there's no data, but 3 months or 6 months, maybe a year, let's see. So the cloud usage for Azure is like each of metric tons, and from May of last year until right now, pretty much right now, there's a time difference for emitting the carbon dioxide from the cloud usage. And there's also cost. You can see the cost here, pretty much around like $1.3 to $2. And then kilowatts per hours, it's pretty similar. And then your cumulative emissions are 29 metric ton carbon dioxide emission. This is directly compared to from New York to London. And they also give you a carbon intensity map, like electricity maps. So this, you can see the low intensity is around the European area. And in our United States, there's more like a neutral, like in the between, from the low and then high in the between. For the high intensity, using mostly carbon, it's actually from China, south of China, and also India, and also Australia and South Africa from like Azure. So it's very interesting. And in this platform, you can also play around with AWS and also GCP. Yeah, you name it. And the way they do it is actually using the method calculate with operation emission and also embodied emission. That's the hardware emission for the manufacturer for data center. And that's basically they took your building data from your cloud usage and also multiplied by some other detailed log here with energy estimate watts hours. So basically you have a compute watts per hour is equal to the CPU hours and also average multiplied by average hours. And also the GPU, so basically taking account about the hardware and storage and networking for memory. So this is all about the cloud. And let's see, so carbon estimate from GCP is different than the AWS Azure because they have different grids estimation here. So that's the method they're doing. Okay, so let's go back to our slides. So key takeaway here, so energy consumption and carbon awareness capability is measured by all these open source tools. And I believe there's a much more open source tool out there. And the good or bad of using ML model or AI like ChatGPT, it's all the time. Like it depends on you. You want to use that or save our planet. And understanding the method and find the resource necessary to reduce the carbon intensity is for our work's software stack. So we can write more efficient code and also choose much more clean energy. So here's my kind of reflection. So how much energy consumption will be converted into water and electricity bill from each of our software like execution or maybe like corporate software usage and cloud usage? And also how much water will be cooling down for the data center? Because right now we only care about the energy usage, but also I think there's a water usage too, but there's like recycled water, but I think water is not like infinity resource too. So we need to think about that way in the future. And how much energy and water could be saved by using this sustainable computing tool? So I don't know. That's a good reflection, a future direction for us to think. And also finally, how much carbon emission will be reduced by using this tool or other platform? That's the way we need to think about. So this is all the resource I plug in. So the David Mentos Professor Sustainable Computing has a lot to look. And there's a Green Coding, Green Software Foundation, and also the white paper from Microsoft is here. And Open Sustainable Technology has a lot of open source packages for each of the environmental resource. And thank you. And here's my contact info. And this is the code I'm just demoing in my GitHub. And finally, I want to acknowledge, so I got the courage to submit the talk here because I joined the PyData Global Conference to be the Impact Scholar. So this recognizes about diversity and equality and inclusion. So being a woman in the like environmental science, sustainability, and computing, this is a very like challenging role and career route. So I think they give us a weekly talk and about giving a talk in either PyData or Meetup. It's very encouraging us to boost our confidence and also share our knowledge with the audience. Yeah, thank you.
Thank you very much. Any questions? Okay, let me bring the microphone. I was told we need to record those questions.
So, so your calculations you demonstrated partway through the talk today, the actual calculations where it was very, detailed. I'm just wondering. I'm a big fan of the work by on the Ethereum virtual machine, in the way that the Ethereum yellow paper calculated or attempted to calculate how much was required for each compute step with regards to the Ethereum and the virtual coin solutions. I'm just wondering, is there any work that goes sort of between this body of work on carbon computing calculations and sort of that earlier work? I think it was by I've forgotten who wrote the Ethereum the yellow paper, but it's kind of it's on GitHub. It's an excellent paper.
So your question is there any paper about theory for this carbon computing? Or
I guess that's one question, and the other question is there some sort of parallels between the work? Is this work on this? your scope of your work is both detailed and very high level, considering the cloud computing, the big graphs, whereas probably in terms of engineers and scientists, in order to make some impact on the cloud computing, we need to kind of perhaps program something into our applications to minimize the energy that it uses.
Yeah. So I think in the Dr. Davis Moon's blog, he actually was a professor here, so this guy, and then he has some paper about not only carbon computing and also some equation and different data center, and also like water consumption too. So basically, if you go into this guy's blog, you can find much more resource, and I can actually show you something here. And that guy was a professor, but right now it's a startup CTO. Okay, so it's called Sustainable Computing, and then there's a way for article about carbon emission data set for AWS and other provider, and there's paper for footprint for data center. I don't know if this answer your first question. And the second question, using this payroll, and they need to much more like software to minimize the emission. I think that's doable, and I think basically you can. So this one's still running. So keyboard interrupt. I think basically you can build upon this cold carbon emission tracker for each of your small software. You can see how efficient to do it. So that's why I say this is my favorite go-to tool. Yeah. Oh, carbon using. Okay, yeah. I think maybe there's some other way from this blogger, and then we can talk about it later. Yeah.
Hi. So I just had a question about more of a general question, just about using data science in general to fight climate change more broadly, like about more topics than just computing centers. I was wondering if you could speak to that.
So your question is like data science in general to fight climate change, and will be different ways, or in terms of like focusing on the data center. I'm just wondering.
Yeah, so I'm just wondering how it can be applied more broadly towards, like, I don't know, just the energy grid in general, like, or just people's decisions to use cars versus other things. How can it affect people's decisions more generally too?
So I think this can affect people from their personal carbon footprint. So from this is also just like corporate software usage or personal software usage from each of the carbon computing. But for our daily life, it's actually like we can grab from, maybe we code every day, and then we see how much carbon we use, and we track, like, for example, I travel from San Francisco Bay to here, so I also like took some like responsible for carbon emission, so carbon footprint. So that's the way we can track to compare. Like I just demo, there's a carbon footprint here. There's some kind of comparison, and then we can aggregate to be our personal carbon footprint. And this can make decision. Maybe I won't take an airplane. Maybe I took the train to Seattle will be better, but it's taking much more longer time. And that's the way I think could be not only focus on data center, but also focus on our daily life. I don't know if answer to your question.
I think I'm more interested in how this could influence politicians, like our decision makers, legislators, and how we can inform them with data, like what that process looks like, like how it could be used to fight climate change on a more global political arena.
I think we can aggregate into this data and then show where is the hotspot, and then compare with the, like I said, so my expertise is kind of like natural disaster, and we know if there's a much more wildfire and also have some carbon emission related, so we can think about is there a correlation in between, and then this can influence about like the political management about carbon emission. Yeah.
So just to address the previous question, I'm not actively involved in a lot of environmental stuff myself, but if you want to be a data scientist for good in that direction, join your local Sierra Club. The Sierra Club sort of nationally does some really, really detailed calculations of stuff, and if you join the club and get to know people and you can find out places you can help, and that would be a great way to get started. Generally speaking, in local politics, they are crying out for people who can understand data, and they don't even know what questions to ask. So there's huge opportunities to do good.
That's cool. Thank you. Yeah.
Okay. Thank you very much.